Hey y'all, can you hear the rain on the tin roof? It's pouring down out there. Now here's a nifty little circuit I put together. Here's a stepper motor. Now this stepper motor doesn't have any feedback, and it's going to replace a motor that had Hall effect feedback. So I had to build a circuit that would emulate that Hall effect feedback from the original motor, so that we can take this different type of stepper motor, put it in the machine, and use my circuit to feedback motion to the machine. I've got an LED indicating that the output, the feedback output, the Hall effect, simulated Hall effect feedback output is turning on and off. Now, the stepper motor on the old motor, for 100 clock pulses, 100 clock pulses to step that motor, we'd have one on-off of the Hall effect. So, I have a PIC 16F84A that takes the step input, the same step clock that's running that motor, takes that same step input and divides those clock pulses by 100. Oh, that's neat. That was a lot of fun to write that code. Here's the emulated Hall effect output that's simulated by my circuit. It has a nice 50% duty cycle, and you can see here that we're at 5.039 hertz. Let's go look at the input, the clock input that's stepping that stepper motor. Spread that time out. There we are. This is the waveform that is stepping the motor, and we have 503.6 hertz. Isn't that a nice little circuit right there? That's amazing. That is amazing. Let's go look at the output again. Here's the feedback output. Bring that time back in. 5.036 hertz. And the clock pulse that was stepping that motor was 503.6. That's perfect. That's a perfect output. That machine won't know the difference. All right, folks. Hope y'all's having a good day. We're getting wet here. We'll see you next time.